Hi everyone, and welcome back. Today, we're talking about something you probably use every day, that little 5-volt DC power supply. The one for your phone, your Raspberry Pi, or your Arduino projects. Most people think these are totally safe, and they usually are, but what about the downstream dangers? What happens if something goes wrong after the power supply itself? Let's explore some potential risks you might not have considered. Firstly, even 5 volts can cause significant problems through overcurrent and fire hazards. If you short-circuit a 5V supply, it tries to deliver a lot of current very quickly. This high current can heat up wires rapidly, especially thin ones. These wires can become extremely hot, melt their insulation, and potentially start a fire. Think about a faulty USB cable or a DIY project using thin jumper wires. A direct short can draw several amps, generating intense heat almost instantly, which is a clear fire risk. Many cheap power supplies often lack robust overcurrent protection, or their protection is set too high, failing to trip until it's already too late. Always use appropriate wire gauges for your current needs and always double-check your connections to avoid accidental shorts. Secondly, there's the danger of device damage. A faulty 5V supply can easily damage your expensive electronics. If the voltage regulation fails, the output voltage can spike unexpectedly. It might go significantly above 5 volts, possibly even reaching 12 volts or higher if it's a poorly designed switching supply. This sudden overvoltage can permanently fry sensitive chips inside your smartphone, tablet, or microcontroller boards, as these components are not designed to withstand such high voltages. While this is less common with reputable brands, cheap, uncertified chargers pose a greater risk, as they might lack proper voltage regulation or degrade over time, leading to such failures. Always prioritize using quality power supplies with recognized safety certifications. Thirdly, we must consider indirect electrocution. Direct electrocution from 5V DC is extremely unlikely because your body's resistance is generally too high. However, an indirect risk exists if the 5V power supply itself has an internal fault. If its internal isolation between the AC mains and DC output breaks down, the dangerous mains voltage, 120V or 240V AC, could leak onto the supposedly safe 5V output. This is a severe danger. If you then touch exposed parts of the 5V output, you could receive a severe electric shock or even be electrocuted. This scenario is rare but does happen, particularly with very cheap, poorly manufactured wall warts that cut corners on critical safety components and lack proper insulation between their AC and DC sides. Always inspect your power supplies for any physical damage like cracks in the casing, which are major red flags, and unplug any supply that feels unusually hot. Finally, a significant danger, especially if charging, involves battery fires. Many 5V supplies are used to charge lithium-ion batteries in smartphones, power banks, and various IoT devices. Overcharging these batteries is incredibly dangerous, as it can lead to thermal runaway, where the battery rapidly overheats, catches fire, or even explodes. A faulty 5V supply might not regulate current or voltage correctly for safe charging, potentially pushing too much power into the battery. While good battery charging circuits are usually built into the device itself, a bad power supply can overwhelm these protections or bypass them altogether. Always use the charger recommended by the device manufacturer or a high-quality, certified alternative, and never leave charging devices unattended for extended periods, especially if they feel hot. So, while 5V DC power supplies appear harmless, they carry potential downstream dangers ranging from fire and device damage to rare but serious electrocution and battery fires. Always prioritize safety. Use quality, certified power supplies, regularly inspect them for damage, and be mindful of your DIY projects by using proper wire gauges and installing fuses where appropriate. Thank you so much for watching this video. I hope you found this information helpful and thought-provoking. If you learned something new, please give this video a thumbs up, and don't forget to subscribe to the channel for more safety tips and electronics insights. Your support helps us create more content like this. Stay safe out there.